Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. In this video, I will explain to you on the real zeros of polynomial. So first of all, let's talk about zeros and their multiplicities. For example, you have this polynomial here. State the multiplicity of each zeros. Okay, so that is the question. So we know from here, one of the zeros is 2. This one, your zeros is 4. And for this factor here, the zeros is minus 1. So what is the multiplicity? Multiplicity is the power of this factor. So for zeros of 2, your multiplicity is 1. For 4, your multiplicity is 3. And for minus 1, the multiplicity is 2. So altogether, your zeros, you have 6 altogether. 2, 4, 4, 4, minus 1, minus 1. Exact number of zeros from the first term if you expand it. So you have x to the power of 1, this one x to the power of 3, and this one x to the power of 2. So when you add up all of the power, the total is 6. So this polynomial has 6 zeros. Now let's look at the second example. Find a polynomial fx that has a degree 3 with zeros 2, minus 1, and 3, and satisfies the equation of f minus 1 equal to 5. Okay, so let's build the polynomial first. Fx equal to x minus 2, x plus 1, x minus 3. And don't forget to put a in front here because a stands for the leading coefficient. So we have extra information. F minus 1 is equal to 5. So let's use the extra information here. Let's fill in. Whenever you see x, let's fill in with minus 1 and then equate it to 5. So now you are able to find a. So just use the calculator, you can find your a. A is equal to 5 over 4. So you can build the polynomial now. Fx equal to 5 over 4, x minus 2, x plus 1, x minus 3. So if the question asks you to give in factored form, this is your answer. However, the question asks you for polynomial, the general formula of polynomial. So we need to expand all of this and multiply the leading coefficient inside of it. So after you have expanded all, this is your final answer. Now let's look at rational zeros of polynomial. So if you have this general form of polynomial here, the rational zeros of px you can find by using plus minus factor of a naught over factor of a n. Use the symbol plus minus c over d. So what is a c? C is a factor of your constant coefficient, while d is a factor of your leading coefficient. So let's try with this example here. You are given fx equal to 3x4 plus 14x cubed plus 14x squared minus 8x minus 8. So let's find the factor of your constant. So constant here is minus 8. So don't worry about plus minus because the symbol here is already taken care of. So now let's focus on 8. So the factor of 8 is 1, 2, 4, 8. How can you get this? So now let's find out. 1 times 8 is equal to 8. Then you can have 2 times 4 is equal to 8. So the factor is 1, 2, 4, and 8. Now let's see factor for an, the leading coefficient. So leading coefficient is 3. So the factor for 3 is 1 times 3. Therefore, the factor is 1, 3. So now let's conclude the possible rational zeros is plus minus factor of constant coefficient divided by factor of leading coefficient. So let's take all of this number here, divide by 1, and then let's take all of this number again, divide by 3. So you can just write the answer here. If you find a redundant number, do not write it twice, just write it once. Now let us see the Descartes rules of sign. So this is another rule where this formula will tell you how many positive real zeros and how many possible negative real zeros that you can get from the polynomial. So let's see here, you are given a polynomial and this question asks you for the number of possible positive real zeros and the number of negative real zeros. So the way to do this is first just take the question of fx and then we want to find the variation. So what's the meaning of variation? We want to find how many variation from plus to minus or minus to plus. For example, in fx here, we only have one variation, plus to minus. Therefore, since you have one variation, we can say that the possible positive real zeros, you only have one. Now let's find the possible negative real zeros, which is just substitute from your fx, let's find f minus x. So whenever you see x, let's substitute with minus x. And let's solve this. Minus x to the power of 4, this becomes positive. Minus x cubed, this becomes negative. Minus x squared, this is still positive. Minus x times minus 8, this will change, become plus. Minus 8, just leave it like that. So now let's see the variation. In front here is plus. So plus minus is one variation, minus plus is another variation, plus to minus is another variation. So let's conclude how many possible negative real zeros. You have 3 variations, so the answer is 3. However, if the number of variation is more than 1, you need to take the number and minus it with even number. For example, if you have one variation, it doesn't matter, you just have one number. If you have 2 variations, you need to minus an even number, so minus 2. So if you have 2 variations, you must answer it with 2 or 0. If you have 3 variations, in our case like this, just minus 2, so this is 3 or 1. If you have 4, just minus 2, 4 or 2, minus another 2, or 0. If you have 5, it is 5 or 3 or 1. Okay, so this is what the formula said. If the number of variations is more than 1, you need to minus an even number. This formula will make a way if your answer is complex number. So let me show you what I mean here. So altogether here you have 4 zeros later on because the degree n is equal to 4. So now one of your options for answer is 1 positive and 3 negative real zeros. Okay, I take this one here, 1 positive real zeros and 3 negative real zeros. So the possible answer, it may be 1 positive real zeros and 3 negative real zeros. However, you may have another options with 1 positive real zeros and another one is negative real zeros, okay, because we take this value here. So you need another 2 values, right, in order to find a total of 4 zeros. So another 2 zeros may be a complex zeros. So we never know what is our real answer. So Descartes' rules of sign will just tell us what is our possible answer. Okay, so either it is 1 positive, 3 negative real zeros, or 1 positive, 1 negative, another 2 may be a complex number.